Okay, so let's solve this thing. So we're going to end up multiplying both sides by x plus 1 times x minus 1, which is going to clear the fractions on both sides. That's going to have the effect of multiplying the 3x plus 1 times x minus 1, and then the x plus 1 times x plus 1. In other words, we'll end up cross multiplying. That's going to give us 3x plus 1 times x minus 1 is equal to x plus 1 squared, which gives us 3x squared plus x minus 3x minus 1 equals x squared plus 2x plus 1. From both sides, which will give us 2x squared. We'll subtract 2x from both sides, which will give us negative 4x. And we'll subtract 1 from both sides, which will give us negative 2. And this is all equal to 0. Divide both quadratic formula. So we have a is equal to 1, b is equal to negative 2, c is equal to negative 1. So we're going to get negative b, so negative 2, plus or minus the square root of b squared, so negative 2 squared, minus 4 times a times c, all over 2 times a. Okay, that gives us 2 plus or minus the square root of 4. Okay, we have a minus and then a negative here, so we're going to end up adding 4 inside here. And then we have this divided by 2, which gives us 2 plus or minus the square root of 8 over 2. And then if we want to simplify, we can say 2 plus or minus 2 times the square root of 2 over 2, because we broke 8 into 4 times 2, and the square root of 4 is 2, so we pulled the 2 out, and then we end up with 1 plus or minus the square root of 2. That's our solution. Okay, so let's take a look. We said we don't have to do b, don't worry about that. So let's take a look at our simplification problem here. And what are we going to do? Okay, we're going to say we're going to divide everything into two different radicals. Everything that goes in the left radical will be something that is a power of 4. So in other words, we'll be able to take it, the fourth root of it. So when we look at 64, 64 is equal to 2 to the 6th. So we're going to pull out 2 to the 4th from there, which is the exponent that is a multiple of 4. That's the greatest one less than or equal to 6. So we end up with 2 to the 4th, or 16. Over here we get 4. Then we look at the x to the 9th. The largest multiple of 4 that's less than or equal to 9 is 8. So we take out x to the 8th. And we do the same thing and take out y to the 4th, leaving us x times y here. So this then, we can take the fourth root of each of these elements. So the fourth root of 16 is 2. Fourth root of x to the 8th is x squared. Fourth root of y to the 4th is y. So we have that whole thing times the fourth root of 4xy. And that's our final answer. Okay, so now let's take a look at this rationalizing the denominator. And we're going to, well, let's see what we're going to do here. Okay, we're going to multiply by the conjugate of the denominator. So we're going to multiply both sides by the square root of 15 plus the square root of 3. And we're going to multiply top and bottom by that, because what we're multiplying here is just really 1. So on the bottom, we're going to end up with, because we have a minus b times a plus b, we're going to get a factorization then. When we do that multiplication out, we're going to get a squared minus b squared. And so that's going to give us as our new denominator, let's see here. That's going to give us as our new denominator 15 minus 3, or 12. Up top here we have 4 multiplications. We have, so root 15 times root 15 is going to give us 15. Root 15 times root 3 is going to give us plus root 45. Negative root 12 times root 3 is going to give us, or times root 15, sorry, is going to give us negative square root of 180. And then we're also going to get negative root 12 times root 3 is going to give us plus root 36. Well, we have a perfect square here, which is square root of 36, so we end up with 15, this should be minus root 36. We have 15 minus 6 plus root 45 minus root 180 all over 12, which gives us 9 plus root 45 minus root 180 over 12, and you can leave it right there. Okay, let's take a look at the next page, and let's take a look first at problem number 2. Okay, so we're going to solve for the variable here. So we're going to first figure out what's our common base. Okay, it's pretty clear that our common base is going to be 7. So we're going to end up making this 7 squared times to the 4x minus 5 is equal to, this is all going to be equal to 343 is 7 cubed, and then to the 2x plus 1. And so that's going to give us 7 to the 2 times 4x minus 5, or 7 to the 8x minus 10 is equal to 7 to the 3 times 2x plus 1 is 6x plus 3. And so now, since the bases are the same and the values are the same, we can just make an equation out of the exponents. Get 8x minus 10 is equal to 6x plus 3. So we end up with 2x is equal to 13, x is equal to 6.5, and that's our solution. Okay, let's look at the next one. Now we have 1/8 and we have 32, so we're going to have powers of 2. So we're going to end up with 2 to the negative third, and again, 8 is 2 to the third, so the reciprocal of that is 2 to the negative third to the x plus 5 is equal to 2 to the fifth, which is 32, to the x minus 3, which is going to give us 2 to the negative 3x minus 15 is equal to 2 to the 5x minus 15, which is going to give us now negative 3x minus 15 is equal to 5x minus 15, and that means we have, when we add 15 to both sides, we get negative 3x is equal to 5x. Well, that's only true when x is equal to 0. That's our solution. Okay, let's take a look at our next problem. All right, we want to solve by completing the square. All right, so let's do that. Okay, so first thing we're going to do, so writing out 3x squared minus 9x is equal to 10. We're going to divide everything through by 3. That's going to give us x squared minus 3x is equal to 10 over 3. So now we want to do what we need to do to make the left side a perfect square trinomial, so we have x squared minus 3x plus, we're going to take half of this coefficient, which is negative 3. We're going to take half of that and square it and add that to both sides. So that means we have to add plus negative 3 over 2 squared. Okay, this then factors to x minus 3 halves squared is equal to, and then this is the same thing as saying 10 thirds plus 3 halves squared is going to give us 9 over 4. And when we give these a common denominator, we're going to give the common denominator of 12, so we're going to end up with 40 over 12 plus 27 over 12 is going to give us 67 over 12. So this is all equal to 67 over 12.